We're into our last presentation here before our roundtable. Pretty excited about this presentation from SERA Architects, which is a really an innovative architectural firm out of Oregon. They do quite a bit of work in the northwest United States and California and Vancouver. They've been working very diligently developing technology and integrating that use of that technology into their day-to-day practice, doing some very interesting things with VR and AR to test sustainability at the early stages to create a more predictable process. So less focused on, obviously still measuring the outcomes of their work, but very much focused on predicting how things are going to work. And this is very close to what we do, what we usually talk about here at CanBIM, the use of technology and how this can be applied to sustainability. So very excited to introduce David Johnson and Brian Stevens. David is a veteran in the architectural community, 20, 30 years experience, you can correct me on that, across the United States. And Brian is an expert in the use of technology, and he's going to demonstrate some pretty neat stuff for us. So I'd like to invite them to come on right now and get started. Just a reminder to everybody, please ask questions. There's a panel where you can fill out questions, and I'll get those to David and Brian. And I'd like to thank our sponsors, SolidCAD, Building Point Canada, and Autodesk Construction Cloud. Very grateful for their support of the organization, as well as all of our sponsors. And with that, I'll turn it over. Thank you very much, David, for joining us.
Thank you, Tom. It's our pleasure to be here today. I'm going to start off by just expressing our gratitude for the opportunity to bring some of this thinking to you today. And I want to encourage people at the end of our presentation to reach out. This is intended to be an open platform and an open set of ideas that we want to share. We're going to need every single minute of this presentation, so I'm going to jump right into it. We've given this as a course for AIA credit, but what we're trying to do here is we want to visualize positive outcomes, not just reduce the negative. We want to use VR and AR to visualize sustainability in the built environment. And we want to tap into all of the energy and enthusiasm that young professionals bring to this. They've been playing with games on the computer for a long time, and now we have VR, and how can we bring that into our practice? We use modeling, as do most firms, to understand what it looks like. And Brian is one of our experts in this. We've embraced VR and AR as part of our design practice with our clients and contractors and stakeholders. It's very important. We're going to show you a couple of examples. But we've been challenging ourselves to imagine environments that we could work in that would help us understand what sustainability looks like. What if we could, in the VR environment, understand airflow? What if we could identify where there's going to be issues of glare in the environment? And what if we could understand the benefits of view or a biophilic response? And biophilia is a big part of our practice. So what if we could actually add gauges that would measure it? Or how about entire pull-in dashboards? So if we wanted to understand the performance of an environment, could we, in a VR experience or design environment, could we have a screen that would pull in from the side to actually understand what the outcomes are of our design? What I'll show is that we have all these tools at this time. We just don't have them in one environment. What if we could click on something and identify its properties, its materials, its circularity? So what is the state of the art? These are the typical tools that we get. And the problem with these outputs is that they're done by an engineer, very qualified engineers, but it's disassociated from the environment that we work in. So it's an iterative process where we give them the model, they run the test for lighting in this case, and they give us the results. And then if we want to make a change and iterate again, we have to go back and schedule time with the same skill set of an engineer, and he's probably not available that week. So how do we bring these tools into the environment that we design in a predictive way, so that we don't rely on images like this days after we give them the output, or analyses like this that could easily be in our design environment. I think you got the point. When we looked around, we said, well, what other industries are succeeding in this? You know, we see that the you know, now we have a complete scan of the human body. We could scan a body and identify where issues are. You can highlight a complete scan of a body and identify where those issues are.
So we saw an opportunity
medical
to fundamentally change how we visualize cancer by turning 2D MRI images into 3D holographic.
Sound off. The medical industry has been quite advanced in its use of AR and VR, merging those analytical tools into the patient care environment. The automobile industry has been quite advanced in its use of computational fluid dynamic analysis. It could be a static representation, or it could be a virtual representation, such as this. Looking at the airflow inside of a car. Why can't we do the same thing in our buildings? So what was our value proposition for us? This started when we took the third floor of this building for ourselves in Oakland, California. And the project starts like it does with any other design, a freehand sketch on the kitchen table by me. And then we had the entire floor cloud point scanned to so that we would have a jump start on a model. That information was then translated into a BIM model for us. That was pretty good, but it actually represented all the flaws. So we have now we have a two-dimensional plan of the space based on a cloud point scan that we used to Autodesk products in this case to model the space and to solve our design. Pretty standard fare. But when we started to look, well, simultaneously, we are designing the environmental performance, and we're a believer that our staff and their health and their well-being are one of the greatest assets that we have. So what you're seeing here is we're dropping in ceiling fans. They happen to be by the company called Big Ass, and we want to understand what is the performance going to be. So the typical output from the fan company was to give us images like this that look at temperature gradient and airflow. And then because that's actually solid data, three-dimensional solid data, it can also be cut through and represented as planes. And it got us thinking, this is a lot like medical imagery. We could have that clipping plane or that slice, like an MRI, slice through any part of our space to understand it. So I asked them for the data. And what they said they couldn't supply the data, but then they provided this a vectorized image of the airflow for us, which was helpful. But I challenged Brian. I said, what if we could visualize what it would look like to understand the airflow in VR? Brian created this little clip, and I said, well, could we also create a VR clipping plane in that environment? This isn't a real VR clipping plane. This is a simulation, as a lot of the things are that we're going to share today. But imagine if you could be in the VR environment and have the performance of the fans be understood in any clipped plane that you wanted to, any slice that you wanted to in that VR environment. in our own practice, Brian, jump in if you want. In our own practice, we use VR modeling. Here we are showing the sun passing across the sky so we can understand the shape of the building. What this is, it's a designer who's actually creating a light fixture in a VR environment with a tool set that Brian has brought to our practice. And so she's actually created that light fixture. That was then captured and then dropped into a BIM model into the VR experience. So it could be looked at, understood by the client and approved. And there it is built in the space, looking much like what that designer created in the VR environment. Likewise, we're using it to understand the dimension of space. This is an outdoor experience where we're using the tools to change the geometry in VR live. The discussion here with the client was, what's the right height for this canopy? You see the dimension being displayed there, and imagine being able to finalize that decision with the client in VR. Pretty cool.
That's right, Dave. So what VR gives you the opportunity to do is experience a space, how it's going to be experienced in reality. It performs completely different from sections and elevations that we're all used to looking at. And it's super important to be able to analyze designs that way to get a better understanding of what we're actually designing. But the point of this presentation, I think, is to go one step beyond what we're doing currently. Because I'm kind of a geek, when I put this together, I thought about, okay, so consider Tony Stark. He's just a normal guy. Maybe he's kind of like a designer in a way. He doesn't really have any superpowers, but when you put a heads-up display, a real-time informative heads-up display on him that gives him real-time access to lots of data, he's able to create more favorable outcomes through the use of that data. So he's combining his intellect with the computer's data and merging that into a superpower. I think the next slide kind of just shows that heads-up display. This is of course all made up. It's Hollywood, but it gives you an idea of the amounts of data that we can bring into the experience. And in our in that previous example that Dave showed, this is what I would imagine a designer's heads-up display would feel like in practice, giving you access to appropriate data when you need it as you're designing, so that you can make better informed decisions about what you're designing, and being able to measure the outcomes before anything's built, and even before you send your design off to be analyzed by a third party. Even if that data is presented to you in a rough, like noisy format, because of the limitations of computational power on your desktop or in your server room, I think that data is really important in making good decisions.
So Brian's going to get ready with his headset. One thing that we've learned is that even though Brian is skilled at VR, it's hard to be in VR, draw, and narrate at the same time. So we're going to tag team this. We're going to show 3 sketches where we've mocked up 3 different ways that we chose to illustrate predictive design in the VR environment, building on the case that we just made. This is these are mock-ets. Some of this is actually computational tools that Brian has written, but most of it is we're exploring. We actually had a dozen different cases that we were inspired to show, and we just decided we'd do 3 different ones. So we're going to look at direct sunlight. So we've created a model that has some problems with daylight that we can address, and Brian's going to show you how that works. We've imagined how we could understand in VR what sound what the acoustic properties are of the space. And so we're going to show you how we've used light as an analog for sound to visualize sound in a 3D environment in VR. And then lastly, we're going to tease a little bit about how could you understand what biophilic responses your design is going to elicit while you're doing the design. So, so Brian, I think I'll give you the screen, or you can share your screen. I'll unshare.
Right. Share mine.
And so you can share now. If we were in one place, this would be easy, but we're probably in 350 places together today. So.
Can you see my screen, Dave?
Yeah, I can. So, so you see, Brian just put on a headset. We'll tell you what the make and brand is of that, and he's stepped into this made up space that we created. It's a little bit jerky when somebody's in VR. So we'll show you how we've helped that. But what Brian can show here is he's created a heat map on the floor. So this, like here, he's just toggled on a heat map to understand the light intensity in the space. Pretty easy tool. Why not have access to that while you're designing, so you can understand where there's a problem? That red spot there indicated that we have a problem. So what Brian's
direct light problem.
Yeah. So what Brian's going to do now is going to drop a camera that's going to be like a third person. So he's just dropped a camera in there, and he's turned on part of our tool set here. So now Brian's going to fly over and move into the screen so we can see what he's doing. So what these little sunlight indicators are is they're the hours of light that are incident on the working surface during a design day. And what we saw from that heat map on the floor and from these indicators is we've got some that have little or no light and some that have 8 hours of light. So what Brian's going to do here is he's going to draw sun shading. And as he's drawing the sun shading, these are vertical sunshades. We could have drawn them horizontal or in any pattern the designer wanted. But as you see, the indicators are showing the result of the sunshades that he's drawn, meaning there's fewer hours of daylight incident on the work surface. So he has attained instant feedback in the design environment. He can see those lights just like we see them. You want to draw another set?
Oh, you bet. Actually, the first set that I was drawing, originally I thought that it would be better to have horizontal. I'm going to try to do this without running into my blinds here. Something like this. But then that was my instinct, but I was kind of proven wrong, and I realized that why I was proven wrong later, because there's a lot of light that's coming in from like the western exposure of the building and coming in at a really shallow angle. So this whole experience just let me, I mean, it kind of, I'm not a lighting designer. A lighting designer might have had an instinctual path forward on this, but it certainly taught me as I was drawing it. The data informed my decisions about what was ideal in this case.
Okay, let's go to the next one.
All right.
So here, we're just to show the different modes that you could be working in. This is like a wireframe view, transparent. We could have chosen any. It's a little bit blurry on my screen. Sorry about that. It's probably a transmission issue. And what we've dropped, instead of those little sun icons, now we've dropped in these spheres. And the spheres are sensitive to light. And so what we're, like I said, what we're trying to do here is visualize acoustics in a VR environment. So we're using light as an analog for sound. So what Brian can do here is he can highlight a surface and give that an acoustic property. And the sphere then is going to show that it is seeing less light. We could change the intensity factor, which would then correlate to the acoustic absorption factor of that surface. He can also choose another surface just to dampen the sound more, so that now he's dropped in an acoustic surface on the ceiling, and then lastly on the floor. And so you see now with now the spheres are seeing no light, so the space would be very damp. You can imagine we could refine this tool so that there would be acoustic properties associated with the settings, with the attributes that is given to those planes. Let's go to the third one. Right. So now we are in our space again. And biophilic design is very important in our practice right now. We work with a number of clients that really see the value of it. And what we did is we brought it into each of the 5 different focus areas of our practice. What we're showing here, it's a little bit blurry, sorry, is we've invented a scrolling tool that is indicating or mocking up the biophilic response that would be elicited in that space at those stations, at those chairs. So if we, and these would be visual connection with nature. Are there biomorphic forms? Do you have a view? Is there a sense of mystery? And so Brian, if Brian drops in some greenery on one of the walls, or I'm sorry, trees outside. So now I've just turned on the trees. The indicators would indicate the biophilic responses that would be experienced by the people in the space. That's easy. What if we dropped in some greenery on the wall? You would imagine that these same indicators would then start, there would be more spaces on the inboard chairs that would be having access to nature. And then we thought, well, if it's not all going to be, we all aren't going to be in an open office environment, what if we created a place that would be more private, secure, or mysterious even? What if, this is blurry on my screen, what if we had a ceiling mounted screen in this case to create a more private space, and then the spaces in there would have a sense of refuge, security, different than the other spaces. And so the scrolling tools would indicate, or the scrolling words would indicate what biophilic responses have been evoked in those spaces.
Thanks, Dave. What I like to kind of think about this as is almost like a biophilic tapestry that you are experiencing in 3D. Again, I apologize for how blurry it appears on your screen, but when I'm flying through this, I'm getting more of a sense of, like, when I'm on the exterior wall, I'm getting a lot of visual connection with nature as the predominant feeling. As I go towards the interior space, I'm getting a biomorphic forms and patterns. It's more, so this is a kind of like a way of representing data through a soft, more experiential way. So it's not a hard chart. It's not like hard data. It's more of like an artistic representation of data.
We could have turned these into dials or a dashboard or a pullout or a plan key indicator, but we're here. The goal of our presentation was to inspire some thinking about different representations of data.
And how a designer would like to see that data, I think, is important. All right.
I think we'll go back to the PowerPoint. So I'll share my screen now. So we posed the question, and I hope that Autodesk is in the audience. I hope that there's some software companies that'll queue up some questions here for us. But we posed the question, what if we could visualize or gamify sustainability, especially for young people? What if we could see healthy design, healthy materials, and predict performance? What if we could, in a VR, visually experience thermal comfort, radiant heat, cooling, and air movement, rather than relying on static models? What if we could visualize glare, light, contrast as the sun moves through the sky in our VR model? What if we could see noise or sound? What if we could predict effectiveness in biophilic design? And then we didn't get a chance to visualize this, but we played with it a lot because we do have some people in the office that are sensitive, that have some problems with pollens. So what if we could see odor or allergens before we build the space? And what if we could analyze complex performance relationships in a visual environment? Movement, light. So Brian, why don't you share what the tools are that we use to create this?
You bet. So I modeled everything that you saw in that demonstration in 3D Studio Max. We use Unity 3D for our for building all of our applications, whether it's desktop or mobile. Just because of the access to writing code, we have a software designer on staff that can create that code. That first little vignette was actually hard coded and it's a working demo. For hardware, we're still using the HTC Vive until something better comes along.
So I guess we'd love to hear your thoughts and questions. And so Tom, I think it's all up to you. And thank you very much for letting us share.
Very much for sharing what your firm's doing.
Trying to stop sharing. There we go. Stop screen sharing. There we go.
Yeah, and Brian, you I was checking out your LinkedIn profile. Man, you got a great beard going compared to the LinkedIn profile.
It may be a little bit due to our times.
There, right?
I didn't want to let this opportunity drop.
Yeah, it's a stunning look. Like you look like a scuba, a wilderness lumberjack scuba diver.
I probably needed more than a jacket to make up for that, but I tried.
It's not. I mean, that is one of the challenges of this whole technology, right? It is hardware intensive. You got to bring a supercomputer along with you when you visit a client, or you bring them into your environment in your office. The other big challenge that I've always experienced with this is that it's, VR tends to be an individual's experience. It's very hard to tie a group together to experience the same thing at the same time. Have you thought about that? Are you working on any, with the platform you seem to be developing, are you working on a shared experience or considering maybe a cave or some other similar technology that would allow people to get an immersive experience?
Brian, you should explain how we've set up our two offices to be able to share VR.
Yeah, so one of the things we've actually been developing is a multi-user experience, so that we can have our VR room in Portland be linked to the Oakland VR room, and by stepping into each of those rooms, participants can join each other in a virtual space as well. It's really cool to be kind of riding the coattails of the gaming industry here, because right now graphics hardware is continuing to just become more and more powerful. Unity is used to create games, and it's that and Unreal Engine is they're both like super powerful tools. So we can kind of create a gaming environment with our VR models, and the industry is supporting us. Maybe it's not the architectural industry, but it's the gaming industry that's supporting us, and we can use those tools to further our own goals. Likewise, hardware is getting cheaper and cheaper. So we have these rooms that we've set up, but more and more we're going to see that technology, that hardware crammed into a laptop that's a pretty decent size. So we're going to be able to like pack a VR rig and a laptop in a backpack and just go to meetings that way, wherever we may be.
Yeah.
We're not going to be like tethered to these lighthouses anymore. We're going to have inside-out tracking so that it's just the headset that we're carrying along with us and not a whole bunch of extra hardware. So I'm really excited about the future. I think as design professionals, we just need to be thinking about that, where the future hardware is going to be, because it's going to be here before we know it. And how can we start using that? We need to think about how we're designing these applications now before that hardware is ready, because you want to be like there when they are and ready to use it. So that's what we're trying to show.
Yeah, well, I think it's awesome. It's one of the better examples I've seen of an architectural firm utilizing these next generation tools to actually do analysis to refine their work. What I've seen more often is using these immersive experiences to have client consultation and get user groups into, say, a hospital operating theater, so they can understand how the ergonomics of the room work and whatnot. Have you done that sort of consultation before, where you brought clients in so they can actually experience the design and gotten feedback?
We have, and it's been pretty cool. And we've actually done a clinical environment in VR, and it was the design I was working on was so optimized. The footprint was, they just optimized the heck out of it. Fit as many clinical rooms in it as they could. We got them into VR, and they were like, "Whoa, this is too optimized. We don't have room to move around at all." And that's where I think VR is really good. Obviously, I mean, it gets you into the space, so you can learn a lot. And going into the future, I mean, that knowledge as you're designing is going to be really important to optimize space and to be able to pull out the best of a building in terms of.
Tom, we're bringing this earlier and earlier into our engagements with our clients.
Mm-hmm.
So we'll bring them into a VR environment of a very early design. So rather than waiting and using it as a representational tool near the end, they get to fly around like Superman and visit any part of the space that they want to, or especially the exterior in the 3D environment. And we're just finding it very useful to understand as early as possible what it looks like. And now what we're trying
value proposition
where we're going is beyond what it looks like to how is it going to perform.
Yeah, you've got a value proposition internally as well, because if you can get that level of client engagement and a validation of your design direction before you produce drawings, that can save you a lot of rework time later on in that consultation process, right? So, I mean, that's just one of the advantages of working this 3D environment, and this technology is one of those tools that can kind of bridge that 3D environment to the client experience. So, yeah, very, very cool. There's a couple different questions here I want to make sure I get to from Clint. From a predictive design perspective, is it clear how this helps the customer experience so really the question is, how does SERA leverage the predictive data from post-occupancy performance verification? I don't know if I did a very good job of reading that.
Yeah, I can't think of an example where we have delivered a model so that it can be compared or be used to monitor performance after the building's complete. Brian, do you think we've done that yet? I don't think so. But
possibly Edith Green, but
yeah, maybe Edith Green. So that was a governmental building. So that was really early. But we do see already in the industry tremendous benefits for use of VR to do operations management of facilities, especially industrial facilities where
Right.
The information of the operational manual is seen in the same environment as an augmented reality view of a widget that's gone wrong. And you'll have 90 widgets in this assembly, and with augmented reality, you use that environment to help you understand what widget has gone wrong. We just haven't gone there yet.
Yeah, no, I can see the application, especially on the manufacturing side. I'm sure they're doing this where they're
huge.
Stimulating the worker experience to make the most productive environment possible. So a question here from Hamad. What is the appetite from the marketplace? Are government and private clients engaging you more for this tech on projects?
We've started early discussions with Autodesk and a couple of other software companies that are interested in advancing these ideas. So they see value. We see value. I think this might be a case where we're probably ahead of the curve and people don't know what they don't know.
Right.
But what we do know is that once you've worked with a client in the VR environment, we do a lot of work for Google. And once you start to work with them in the VR environment, they know its strength and demand or expect it to be in the next project. So it's we have clients that see the value of it now, and it's just part of our practice now.
Yeah, you know? You're raising the bar of client engagement. Yeah, it's pretty cool. Like, it's some of the things that I hadn't thought of. What you guys are working on around, studying, say, shadows in real time. The technology and the hardware is going to get to a point where you can move a chair and see the shadow on the floor change in the virtual space, or open and close a blind, or stick your hand out and see your shadow maybe. So it's pretty interesting where it's going, and you can get to that level of simulation. It's one thing to have these sort of color-coded visualizations of a 3D model and sort of slicing and dicing and trying to understand it, versus being in the space and being able to interact with it in real time. I also thought what you're doing around combining that microclimate analysis visualization with a VR experience, so that you can actually see, say, air currents and odors, as you mentioned. These are certainly interesting things. And then looking at
computational fluid dynamic analysis is so standard.
Yeah.
Why can't we just merge the tools and imagine this clipping plane that you create yourself anywhere you want in VR to understand that solid data?
So you're obviously creating some interesting tools here, and you've made the investments internally to bring on staff that have the technical ability to develop this sort of thing in Unity and whatnot. Do you have plans to commercialize this? Could somebody come along and buy a seat of your software product from you, or what are your plans there?
I think what we've been doing, Tom, is we've been trying to kind of capture the low-hanging fruit here as much as we can with the limited capability we have to write code, and hopefully that can start a dialogue with, like Dave mentioned, with Autodesk. We're designers, and I think that's what we do best. So we can suggest this as a potential path forward for the software, and hopefully others can actually commit the resources to creating this software. We're going to continue to play with this internally, because that's kind of who we are at SERA. We love innovation, and we want to see it go forward. But we're not going to be selling software, at least like this, anytime soon, I imagine.
Yeah, we've given this presentation a couple of times, mostly just to stimulate thinking, and we would like this to be open source. We would just like to stimulate this type of thinking to get better designs faster and sooner. Mm-hmm. These tools could be used to measure carbon, to quantify energy. You could visualize embodied carbon. We just don't. We think that this is the direction that we need to be going.
Yeah.
How do we understand positive design sooner and faster? And so we don't really, like Brian said, we probably aren't going to be writing the software. We just want for the industry to move.
Yeah, there's definitely a handful of leaders around the world that are driving this. You can look at what Synchro's doing. Greg Demchak's been doing a lot of innovation in this area. I'd encourage you to look that up. But they're simulating construction schedules and construction sequencing in a 3D environment in a VR space, and it's very cool, and it allows you to understand and dissect a project and get to a higher level of refinement, and that's really like dollars and cents. And I think on the design side, I mean, traditionally, I've been involved with projects as a construction manager where, as part of the scope of work of, say, delivering, whatever facility, there's a requirement to actually build physical mock-ups. And that's, you're literally building a room in a warehouse to simulate what it's going to be like in order to work through a design consultation process. And you can imagine how expensive that is. It's like building a house, or multiple houses, temporary, and then ripping them apart and they go into the dumpster, right? Whereas with this technology, you can quickly mock up, that same sort of experience and do that many more times at, not even a comparable amount of cost. Yeah. So it's pretty cool stuff. I think it's going to be growing. From your
just add to that thought, Tom, the benefit for the construction industry to save time and money is clear. Mm-hmm. The value proposition for the occupant of the building is in the performance of their people. Yeah. And we know that is much greater value than the value of the property of the building. Yeah. So where we're going is, yes, we need to understand cost and construction speed, but how about the wellness and the performance of the space from a human standpoint?
Yeah, I thought that was really interesting. Like, I mean, it's how you're sort of like measuring each chair in the office as which one performs best. I mean, you might have an argument amongst the workers saying, "Well, I want that chair slightly close to the window," or whatever the case is. I thought that it's very interesting. So, what the use of this technology? What do you think is the biggest opportunity for measuring sustainability? What aspect of sustainability does this allow you to understand the best?
Well, we visualized here the occupancy of the space and the attributes of wellness and how the space is going to perform for the person. We think there's tremendous value there. I think that climate change is probably another direction for this, and we are now doing embodied carbon modeling of all of our projects, and understanding how this tool can help you understand the choices you're making in the embodied carbon in the design environment earlier. It's probably a simpler.
Just adding carbon value to the families that you're using.
Yeah, all of these elements in the virtual environment have attributes. Mm-hmm. So just like you can set the color and the shape, you can have other attributes of the embodied carbon. You could have a chair that has manufactured data that's tied, that has an API. Mm-hmm. So you could run your embodied carbon model from an API that's linked to the manufacturer's data. We're doing this now on material properties for human health through a software called Matter by a company called Giga, where we are able to understand the properties of a material as they're described by the manufacturer through a live API. So why can't we? All of these things exist. So and if VR is going to be a way to understand data visually, we're visual people. We are visual creatures. We have been trained for eons to understand our environment visually. It's much faster than reading, than calculating, than hearing. We are visual people. So why can't we access the data that's out there as we were trained as humans in the visual environment?
Yeah, what you mentioned about the acoustics as well, I think that'd be really interesting if you could model a space and then speak or simulate noise in the space and have real-time feedback when you drop a three-dimensional object into a room to see how the sound absorption or echo changes in real time. I mean, that would be just so amazing. And
all that software exists.
Achievable.
All that exists. We just need to bring it into that visual environment for the designer and for the client to understand it, so they can make a decision.
So what do you think the barriers are that are in the industry or otherwise that slow down accomplishing what you showed or what's possible?
Yeah, we talked about that a little bit. As hardware gets smaller and smaller and more condensed, I think it's going to be, obviously, it's going to be more widespread. Right now, not everyone has a VR rig at their desk or in their homes, but we're going to start seeing, as the prices come down and power increases, that's going to be more of a thing. If nothing else, your teenage kid's going to be able to let you borrow theirs, and you can use that. But right now, a lot of it's just hardware, and that's continually improving.
Yeah.
I'm old enough to remember when people questioned if there was value in putting a design into 3D, where 2D CAD was the standard, it was good enough. Do we really need to draw it in 3D? And now we understand that that's the fastest way for us to move through the decisions in a project. And we can harvest the most data the most quickly. So I hope we're near a tipping point. I don't think there's any barriers. I think it's just the industry understanding and having the confidence to bring this on and to take this on.
Right. And it's a skills thing too, right? You have to devote the time and effort and investment to develop the skills and sometimes even the technology in your own firm to get to that level of sophistication. So, excellent that you guys have gotten there.
It was the same argument with 3D CAD, right?
Yeah.
Oh my God, that's a special skill set. Only 2 people know how to do that. Now, most of the young people in our office don't know how to open a 2D drawing.
Yeah, and they probably don't want to either. So maybe we have one more question maybe here we can plot before we run out of time here from Derek. Once you merge the engineering data into the model and then change your parameters like adding blinds, changing acoustic properties of walls, etc., how do you get around the iteration aspect of an engineer ultimately still needs to recalculate or stamp? Do you think that this red tape could hinder the process, or is this an exciting new opportunity?
So great question. And I didn't say it before, but we do not think that we're going to be putting engineers or computation analysis out of work. Mm-hmm. We think that there's great value in understanding to the minute detail what an engineered solution is, how it's going to perform. Invaluable. What we're trying to do is bring indicators of that performance into the design environment rather than waiting for that refined analysis feedback loop. We're desiring to have that feedback be live so the designer can understand at an indicator level, is he creating something good or is he bumping into something that he was trying to avoid? But we see that the verification and the work by engineers, like acousticians, lighting designers, we aren't going to put them out of work. We just want to bring that information into the design environment early, because that's where the value is.
Yeah, it'd be really interesting if you could combine it somehow where, say you were in the VR experience and you deleted a beam and the whole building collapses around you, sort of like Pitfall, you start over again. I mean, it'd be interesting if you could get those real-time feedback for minor changes even.
I liken this a lot to the work we're seeing done with autonomous driving. I follow this a lot, and when you have a car that is like constantly on the lookout, like 360 degrees as you're driving down the highway, it has so much more information and is able to make split-second decisions that as a mere human, I can't do that. I want that computer to back me up as I'm driving down the road. And that's kind of how I see VR and all of this data that's being analyzed in real time falling into place. I can make better intuitive decisions than a computer can, but the computer is going to see things that I'm maybe not paying attention to as I'm going down this design road.
There's a great quote that I read recently. It's smarter than I could come up with myself. It said, you can have data without information, but you can't have information without data. And so what we want is that information from the data that probably already exists.
Another way of visualizing it.
Yep.
Well, it was a really great, guys. I appreciate the time and effort to put this together, and I really appreciate that your firm is willing to share your innovative work here. I think it's great for our community to learn from this. And just a reminder to everybody, these videos are available online, so we'll make this available as soon as possible if you want to share it. Anyways, thanks a lot, guys. I really appreciate it. Just a couple housekeeping items. I just want to thank our sponsors once again: SolidCAD, Autodesk, Cloud Construction Cloud. Sorry, they're new, and Building Point Canada, the platinum sponsors, and all of our other sponsors that help to make this possible. And yeah, if you haven't done it already, please sign up for a mailing list. That way you can keep track of what's happening and what's upcoming. Anyways, thank you very much. We're going to move on, and we'll talk to everyone at our next session, which is the panel. So thanks a lot. Appreciate it. Take care, and we'll talk soon.
Thank you. Bye-bye.